So here's an example of a specific heat capacity problem. When ice melts, it absorbs 0.33 kilojoules per gram, so we're talking about per gram of ice. How much ice is required to cool a 12-ounce drink from 75 degrees Fahrenheit to 35 degrees Fahrenheit if the heat capacity of the drink is this that's given? All right, so I think the first thing to do is to break this up into parts. We have two different parts to this problem. So in the first part, it's saying that when the soda gives off this amount of heat, so remember that all the heat that's being given off by the soda is being absorbed by the ice. So this amount of heat is being given off by the soda, and it's also absorbed by, in this case, 1 gram of ice. All right, so what we need to figure out first is, well, how many grams of soda are giving off that amount of heat? So this is going to be a small amount of soda. Okay. In the second part of our problem, we're going to take this information. So once we figure out the grams of soda that gives off this much heat and is also absorbed by 1 gram of ice, we can go on to figure out, well, if I have a 12-ounce drink, so I have a lot more soda, how much ice do I need to absorb the heat from that amount of soda, which is going to be a much larger amount. Okay, so we're going to start with step 1. One other thing that we know for our heat equation that we'll talk about in a moment is that we need to have all of the units the same. So that's the very first thing. Okay, so down here we know that we need to have joules for our energy or heat. We need to have things in grams, which we already do, so we're good there. And then we need to have our temperatures in degrees Celsius. So the first thing we should do is go ahead and convert those before we do anything else in the problem. So I'm going to take my initial temperature, which is going to be 75 degrees Fahrenheit, plug it into my equation. That you'll always be given this equation, just have to know how to use it, and we get our initial temperature is 24 degrees Celsius. Our final temperature, so we want to make sure we're cooling the soda down, is 35 degrees Fahrenheit. If we plug it into our equation, we get 1.7 degrees Celsius. And the very last thing is we're given our energy in kilojoules, and we need to convert those to joules. So once we have this information, we're ready to start the first part of our problem. Okay, so let's organize. We know that the ice is going to absorb heat. Okay, so anytime we're absorbing or we have an endothermic process, we know that we're going to have a positive value for Q. Okay, all of that heat that's being absorbed from the ice, it has to come from somewhere. It's coming from the heat given off by the soda. So our drink, okay, this is going to be the one that's releasing heat. So we can think of it as being an exothermic process. It's giving off heat. This should have a negative value of Q, right? So if we go back at and look at our picture, in the very first part of the problem, we know that we have 1 gram of ice that's absorbing that amount of heat. So we have the mass of that. What we need to figure out is the mass of soda, okay? So that means if we're talking about, we know that Q equals mass times the specific heat capacity times the change in temperature. We're talking about the soda in this case, or our drink. So this value of Q has to be negative when we plug it in, right? So why don't we go ahead and manipulate this equation, and we said we need to solve for the mass of soda first. Okay, that's what we need to solve for. If we go ahead and isolate our mass, we have Q is equal to, let's go back. We have our M is going to be equal to Q, and then if we divide by C times change in temperature on both sides, then we'll have our mass isolated. So C times delta T. Okay, let's go ahead and expand this equation because we know that this has to be negative Q, right? We're talking about the soda, so let's go ahead and plug that in. Negative Q over specific heat capacity, and we know that our delta T is going to be our T final minus our T initial. Okay. Again, since we're talking about the drink and that the heat is being given off or released by the drink, this value of Q has to be negative, right? Let's go ahead and plug things into our equation. So I have my mass, and I'm just going to put soda as a reminder, is going to be negative 330 joules. Remember that we had to convert it to joules. Okay, and that's going to be divided by, we're given that the specific heat capacity is going to be 4.18 joules over grams times degrees Celsius. Right? We know that our final temperature is going to be 1.7 degrees Celsius, and we know our initial temperature was 24 degrees Celsius. Okay, so it makes sense. We have a negative on top. This whole part on the bottom will be negative. Those will cancel out, right? Our joules are going to cancel out. Our degrees Celsius will cancel out. We should be left with just grams. So we also have the correct units. Once we calculate this out, it's going to be 3.5 grams of soda. Okay, let's go back up to our picture and the rest of our problem. Okay, so we plugged in this value for energy, okay, but that's for 1 gram of ice. Right? Let's go back down here. So what we can say is that we have 3.5 grams of soda, and 1 gram of ice will cool that down. Okay? So again, that goes back to our picture in part 1. We just figured out the grams of soda. Okay? Our next thing that we need to figure out is, well, I have 12 ounces of soda. I have a lot more soda. So 1 gram of ice is not going to be enough to cool it to that temperature that we want. So I want to figure out how many grams of ice I need for this larger amount of soda. Let's go back down. Okay, now I can start with the total amount of soda that I have. So what I have is I have 12.0 ounces of soda. Right? And then on the bottom, since I'm in ounces, the first thing I need to do is convert to grams. So I have 1 ounce is the same as 28.35 grams. And let's specify that we're still talking about the drink. Okay. The very last thing we need to do is say, well, I know that 3.5 grams of soda is going to need 1 gram of ice to keep it cool, or to cool it down. So I have 3.5 grams of soda, and then I have 1 gram of ice on top, right? So my ounces of soda cross cancel, my grams of soda cross cancel, I'm left with grams of ice. So this will tell me how much ice I need to cool down the entire 12 ounces of soda, and that's going to be, I need 97 grams of ice. And if I wanted to be 100% correct with my number of significant figures, I would say I have 3 significant figures here. I would need 97.2 grams of ice. So that would be my final answer.